What's up, everyone? My name is Mahesa Farrell Djayaputra, hashtag the researcher. And in this AP Physics video, I will be explaining about design thinking process, scientific method, and how I apply it on my AP Physics project. Watch the full video right now. So usually, we've always used the scientific method where we should make observation, think of interesting questions, formulate hypotheses, develop testable predictions, gather data to test predictions, and develop general theories. But now there's a new method called the design thinking, a non-linear process where it's more simple, where it only includes 5 steps. The first step is to emphasize, the second step is to define, the third step is to ideate, fourth step is to create the prototype, and the fifth step is to test. So that is the new thinking or the new design thinking process that we are going to apply for AP Physics project. So for this AP Physics project, we as a researcher would like to contribute to the community by creating a sustainable car crash barrier for the community in order to prevent future accidents and also to prevent or reduce the amount of injuries that are caused by a car crash. So the first step of the design thinking process is to empathize. So empathize basically is where design teams conduct research to get personal grasp on their users' need. Or in the scientific method, it is referred to known as making observations and of thinking interesting questions. Could be from reading your assignments. What the hell? Or reading any books. But for this AP Physics assignment or this physics project, maybe you would know what observation that I have made. Here's a clip from a year ago. Yeah, for the first step of this project, the observation that I found and that I want to emphasize is about car crashes. So that's the first step done. So the second step, which is also part of the first step in the design thinking process, is to create questions. You just think of what sort of questions that you want to answer while you're creating this project and what you have learned from answering these questions. Here's an example. Is it possible to create a car bumper using styrofoam, sponge, and lever? Yeah, I'm gonna find that out. Yeah, so that was an example for my AP Physics project, is to find questions. For example, what sort of material that I would like to use, or maybe what if I use styrofoam or lever or sponge as a material. So that's the first step of design thinking process done, and the second step of the scientific method done. So the second step of using the design thinking process is to define. So what it does is basically, it involves by collecting data from the observation stage to define the design problems and challenges. So in this AP Physics project, the thing that I want to define is the materials used for the car bumper and how it impacts the final force after the car crash. Yeah, I think that's it. Here's an example. Car crash could happen because of the driver, or maybe it's the sensor, or maybe the aerodynamics. Maybe for this project, I would like to focus on the materials and how it affects the impact force. Yeah, that sounds interesting. So, the third step of using the design thinking process is to ideate, or in scientific method terms, is to formulate hypotheses. So basically, it's to create questions whether your products or your solution could work, and then you have to answer it at the end of your project. Here's an example. What if I use sponge, styrofoam, and lever as my material so that I could manipulate the final velocity, thus creating a low impact force? That seems interesting. Let's test it out. So the fourth step of the design thinking method is to make the prototype. This is where things get very, very fun. So basically in this step, all you need to do is to create the prototype. You actually build your solution. For example, in my AP Physics project, what I want to do is to create the bumper using lever, styrofoam and sponge. So that I will combine into one and to create different measures in length so that I could test which length of the bumper works the best. Here's an example. What if I combine this and I put it on a car, and then when you crash, voila! And the last step of this project, well, not in this project, in the design thinking process, is to test. Well, basically all you do is that you have to test your product. Well, in AP Physics, what I did is that I have to collect 100 data. Yeah, so all I did was to crash 2 cars and then test which one is the best measurement. For in this AP Physics project, what I want to create or what I want to focus is to manipulate the final velocity time from the impulse and momentum equation, so that if I manipulate the time, there should be a less impact force during the collision. So make sure to always get ready with your equations and also your theories to prove that your product actually works and to make it as a solution. Here's an example. Final velocity in time 10. Okay, time 10. And also the final velocity minus 30. Okay, that seems pretty good. Let me put it in my data and let me just do that 100 more times. Well, 99 more times. Let's go, Professor Danet. Yes, and I actually did that for 100 times. Well, 300 because I'm testing 3 products. 400 if you count without the product. So, I did 400 of that in AP Physics. But it's fine, it's to prove that my solution actually works. Or does it? So that led me to the final step in the scientific method, is to develop general theories. So basically, general theories must be consistent with most or all available data and with other current theories. So yeah, you basically create a generalization of your product, whether it works or not, and compare it with your final data and also the general theories. Yes, so from my AP Physics project, I could conclude that from the data that the researcher has created, the crash barrier that is a middle length is proven to have more optimal results than the short crash barrier. So students, well, the researchers state that the hypothesis that has been established is not really proven. So even though a crash barrier that is 2 centimeters long proves to be more optimal than a crash barrier that is the longest measurement in length, this is not really the case with the 4 centimeters crash barrier, as you can see from the data right here. Yes, that's all of my data that I've used for my project. So in the AP Physics project, you gotta also mention how or why that your product did not successfully meet the criteria or did not prove your hypothesis, and how it succeeded or how it did not succeed. For example, in my AP Physics project, maybe it is affected by the inconsistent time, where I found that the lowest velocity was not at the proper time compared to the other 400 daters. So that's probably one of the factors why that my calculation wasn't correct, or maybe how that it established a wrong hypothesis. Yeah, so make sure to always give your reasons, guys. And once you've mentioned or found out your errors, make sure to always give yourself a self-reflection. What went wrong, what could have went right. Like for example, in my project, what I can make for major improvements in the future is that we have to work more as a team to calculate the data right, to find and also communicate with the team to get the maximum results. So that is something that I want to point out, that I want to emphasize or maybe improve in the future. Yeah, so that's probably basically it for my video. I hope you find this useful, and yeah, I hope you use the design thinking process and scientific method wherever you are doing whatever you are doing related to science or maybe in AP Physics. And yeah, for those are picking AP Physics in the future, good luck. Yeah, good luck. Think twice maybe, or no, you just go straight in. It's fine. Yeah. All right. Bye.